we had some questions about this type of a homework problem where we're given a few things. We've got 3 here, and initially it says calculate each of the following. One says in grams, but we're going to do number 3 a little differently. I'm actually going to calculate the number of ions. But this problem does a couple of things. One is we're going to convert from grams to moles, moles to grams, moles to molecules, and we're going to interpret the written formula. So let's start with number 1, and it says we've got chromium 3 sulfate decahydrate. Now this is a fun one, so let's kind of start with our number 1 and our chromium 3 decahydrate. So we know we're going to have chromium, which is Cr, and it tells me that I've got a +3 charge associated with it. Remember, when we make a molecule, we want to have that even neutral charge. So we're going to have to look at our sulfate. Now, maybe you want to go back to your book, chapter 2, and they're on table 2.5 of our particular textbook are the common polyatomic ions. Now, in other textbooks, it may be a different table, but you probably have out there some sort of table of common polyatomic ions. So we're going to look at our sulfate. Now, remember, there are going to be polyatomic anions, and because we're dealing with an anion, it is going to be a negative charge. So my sulfate, hang on, we'll do it this way. My sulfite is a -2 charge, and this is a sulfite. And it has the ITE ending, and my sulfate is a my sulfate is a 4, and it's also a -2 charge. So let me rewrite this so it makes it a little easier for everybody to see. And this is the sulfite, or sulfate. So I have a different ending. So we have our sulfate and our sulfite, but it's a -2 charge. So I'm going to have my SO4, which is going to act like a single anion, and it's going to have a -2. Well, we got a problem. My chromium is a +3, and my sulfate is a -2. And so we need these to be neutral. So how am I going to make it neutral? Well, in order to do that, we're going to take 2 chromiums, and if I do that, that's a +6. And we're going to take 3 sulfates, that's going to be a -6 now. And now I've got my +6 and my -6, those are going to cancel out. And so now I have a net neutral, and that gives me this right here in terms of my chromium 3 sulfate. But then our problem says it's got a decahydrate. So this is going to mean I've got 10, because deca means 10, and I have water, H2O. So now I have chromium sulfate, and that's chromium 3 sulfate with a decahydrate. All right, but we want grams, and we're told that we have 8.36 moles. So 1 mole is going to equal, right? 1 mole is going to equal, make sure I'm writing down numbers down correctly here because we don't want to mess up anything. My mole is defined as 6.022 times 10 to the 23 atoms. All right, but we know we can do a molecular formula and find out grams per mole. So let's go ahead and do our molecular formula and find out grams per mole. So again, what I'm going to have available to me is a periodic table so that I can do those calculations. So let's do my chromium. I'm going to have 2 chromium atoms. So that's going to be 2 times 52.00, and when I'm reading it off my periodic table, that is in grams per mole. I'm going to have 3 sulfur atoms, so I'm going to have 3 times, and I'm going to go look at my periodic table, and my periodic table is going to say 3207 grams per mole. And I'm going to go ahead and move my periodic table over here so that you can look at this. So there's my chromium, there's my 52, there's my sulfur, there's my 32, there's my oxygen, which is going to be 16, there's my hydrogen, which is 1.008. So I've got pretty much everything that I need, but I need to make sure I'm calculating the right numbers of atoms. So now I'm going to have 3 times 4 is 12, so I'm going to have 12 oxygen atoms. So I'm going to have 12 times 16.00 grams per mole. And then I'm going to have my waters. So I'm going to have 10 times 2 hydrogens, which is going to be 20 hydrogens, which is 1.008. That's my grams per mole. And then I'm going to have 10 oxygens here, which is my 10 times 16.00, and that's grams per mole. So now I have all of those individuals, and I'm just going to total those up. So we can do this number here. We'll put it on my calculator. We'll do 2 times 52.00 plus 3 times 32.07 plus 12 times 16.00 plus 20 times 1.008 plus 10, I'm going to make sure I'm multiplying, times 16.00. And this gives me 572.37 grams per mole. So we're told from the problem that we have 8.63 moles. So I have 8.63 moles of this material. So I'm going to do my 8.3, I'm saying 63, and it's not 63, it's 36. I read it backwards. And this is moles of our chromium sulfate, decahydrate, and there are 572.37 grams for every 1 mole of my chromium 2 sulfate decahydrate. This will cancel that, and I'm going to be left with grams. So I'm just going to take that number and multiply it by 8.36. And I'm going to get that there are 4,785 grams, but that's not in the right significant figures. We said we had 8.36. So I need to be in 3 significant figures. So this is going to be approximately 447.80 grams. And the reason we round it down is because we want that number to be an even number if we remember our rounding rules. So that gives us one way to work the problem. So this is our first one. Let's go ahead and do the second one. So now our second one says that we are going to start with 4.04 times 10 to the 20 molecules of dinitrogen pentoxide. Well, this die tells me 2, so I'm going to have 2 nitrogens, and I've got 5 oxygens. Okay, 2 nitrogens, 5 oxygens, so I'm going to actually write it this way. So that's how I would write that particular formula from the information that we had. I'm going to have to calculate grams per mole. So I'm going to have 2 nitrogens and I'm going to have 5 oxygens. And we already know, because we just looked that one up, that that's 16.00, and that's grams per mole. And then I have 2 nitrogens, and if I go over here to my nitrogens on my periodic table, my nitrogen is 14.01. So I'm going to put that in there, 14.01 grams per mole. So we have that, my 14.01 grams per mole. So I'm going to go ahead and do my calculation. 2 times 14.01 plus my 5 times 16.00. This gives me 108.02 grams per mole. Now, I need to know how many moles 4.04 times 10 to the 20 molecules is. And that comes back to remind us that 1 mole is equal to 6.022 times 10 to the 23rd molecules. So what we're going to do is we're going to take our 4.04 times 10 to the 20th, and this is molecules. I want in moles, so I'm going to put 1 mole is 6.022 times 10 to the 23rd molecules. And this, remember, is an equivalent to 1. This equals 1. All I'm doing is dealing with my units. So my units are a little different, and that's all I'm dealing with is my units. So that's where that one is going to go. So we're going to take that. We'll plug it into the calculator, 4.04. I'm going to put it in my scientific notation. It's 20. I'm going to hit enter. That's just to make sure I don't screw anything up. I'm going to divide it by 6.022 to the 23rd. And this says I'm going to end up with 0.000670873 moles. Now, of course, we're not going to be carrying all of these significant digits, but I'm going to be using it in my calculator, so I'm just going to leave it in my calculator. And now we want grams, because that's what the problem was asking us for, was grams. So I'm going to take this answer, and I'm just going to write this as an answer so I don't have to rewrite that. So I'm going to take that answer, which is in moles, and I'm going to multiply it by my molecular weight, which is 108.02 grams per mole. And my moles will cancel out, and that's going to leave me in grams. So now I've got that, so I'm going to multiply times my 108.02. And now I've got a number that's 0.07247. We're only in 3 significant figures. 1, 2, 3, only 3 significant figures. So this is approximately equal to 0.0725 grams. And this is 3 significant figures, 1, 2, 3. That is a placeholder, and that is not a significant figure. That is just telling me where it is. So this is another way to go back between grams per mole and moles per gram. So we can look at that one. Now we had one last one, and this one was a little different. We're going to go ahead and do that one. And this was asking for the number of lithium, and I'm going to spell it out, lithium ions in 6.45 grams of lithium sulfate. Now, we looked at our sulfate a little earlier. It's a polyatomic anion. And so my lithium sulfate, sulfate is going to be SO4. And remember, this is 2 to the minus because that's my charge on there. But now we got to look at lithium. So where is our lovely little lithium atom? Our lovely lithium atom is in this first column. So let's look at what that is. If I don't have a periodic table that gives me my oxidation states or gives me how many electrons are going to be positive or negative, we know that this column is usually the plus ones. They're going to want to give up an electron. This purple column right here, the lithium column, is plus 1. This one is plus 2. And then if I look over here for my anions, these are minus 1, minus 2. So we know that my lithium is a plus 1. So now I can go over here and I'm going to put in my lithium, and it's a plus 1. Well, we want to have that balanced net neutral formula. So we have to write that down. So we have lithium times 2 with my sulfate, and that's going to be my lithium sulfate formula. So we've got that issue that we have it already there, lithium sulfate formula. So we're looking for the number of items. So we're looking at the number of ions, but first of all, I have to find out how many moles, because I've got a conversion between the number of molecules per mole, and I have a conversion for grams per mole, but we need to figure out grams per mole. So I'm going to have 2 lithiums, I'm going to have 1 sulfur, and I'm going to have 4 oxygens. Now we've seen oxygen before, so we know that that's 16, and I'm going to have 4 of those. I'm going to have 1 sulfur, and I'm going to go back to my periodic table. It's been a little bit since we did sulfur. So let's go back in sulfur, and sulfur is going to be 32.07. And then I have 2 lithiums, and I'm going to have to go over here and look at my lithium. And lithium is 6.94. So we're going to write down my 6.94. So there's my lithiums, and remember, these are all in grams per mole. So now I'm going to total things up. So I'm going to have 2 times my 6.94. I'm going to add my 32.07. I'm going to do my oxygens. And now I have 109.95 grams per mole. Now, we're told that we have 6.45 grams of my lithium sulfate, but I need the number of moles. So now I'm going to multiply this by 1 mole is 109.95 grams of my lithium sulfate. So there we go. So we can do that. So I'm going to take my 6.45 divided by my 109.95. And this says I have 0.05863 moles of my lithium sulfate. Well, that's only the first part of the problem. I want the number of lithium ions. Well, remember, there are 6.022 times 10 to the 23rd molecules per mole. So I'm going to multiply times my moles. And that's going to give me I now have 3.533 times 10 to the 22nd molecules. But there are 2 lithium ions for every one molecule, because that's what that says. There are 2 lithium ions for every molecule. So the number of lithium ions is going to have to equal 2 times my 3.533 times 10 to the 22nd to give me lithium ions. So if I multiply that by 2, I'm going to get 7.065 times 10 to the 22 lithium ions, but we're not in the right number of significant figures. I'm going to have to round. So this is going to be 7.06 because, again, we want to be in our even number. And so I'm going to round so that I have the even number. So I'm going to get 6. So that would be how I would find the number of ions.